Hey everybody, this is Mrs. Van Sant, and today we are going to talk about percents. We've talked about them a little bit, we've played with them a little bit, and I know that you are really comfortable using them when we talk about things like grades and things in real life. But today I want to kind of dissect it and talk about what a percent really means. So what is a percent? We can see here that I have it split into two different parts. And you guys are good at pulling words apart and finding out what they mean by looking at their parts. So per means for every, just like we talk about with our ratios. There is one cat per bowl. It's a 1-to-1 ratio. There are 3 boys per team. There are 3 boys on every team. So for every is what per stands for. And cent is a word you hear all the time, like 100 cents in a dollar, 100 years in a century. So cent just means 100. Put it together, percent means for every 100. When are they useful? You hear them all the time in real life, but why are we even saying percent? Well, let's look at a few of these situations. What if I said to you, 63 students did their homework last week? You might be like, yay, that's awesome! But wait a second, you don't know how many kids there were total. So what if I told you 70% of the students did their homework last week? Would you still be cheering, or does that kind of change it a little bit? What the percent does is it gives us the part to whole ratio to really kind of look at 63 students out of how many? What if I said 3 pieces were missing from my building set? You might be upset because with 3 pieces you can't finish your Lego build. But if you think about it this way, that fewer than 1% of the pieces were missing. It's not quite as bad now. How about this one? The Cards won 91 games last season. Wow! That seems like a lot of games. But if I give it to you as a percent, the Cards won 57% of their games last season. That's just over half. How about this one? A can of Coca-Cola has 39 grams of sugar. Oh well. But if I give it to you as a percent, that 39 grams of sugar is 325% of the daily recommended amount of sugar you're supposed to have. So you can see that when we use percents, it gives us a better understanding of a number. Instead of just saying 39 grams, understanding that that is way more sugar than you should have in one day. That's what the percent information gives you. So a percent is a part to whole ratio. We've been talking about ratios for quite some time now. But the only difference in a percent is that the whole is always going to be equal to 100. So we'll have equivalent ratios, and the ratio for a percent, that whole is always going to be 100. The reason we do this is because it makes a whole lot easier for us to communicate a part to whole relationship. Instead of having to say this many out of that, the calculations are kind of done for you. You can understand the relationship to the whole better. And they're pretty easy if we use what we know. So you can see over here we have 1/2. I have a 100 grid. It's shaded in half. We know that as a fraction that is 1/2. 1/2 of that is shaded. Well, there are 100 squares. So how many are shaded in? 50. So 1/2 is equal to 50 100ths. Oh, 50 100ths as a fraction can also be written as 50 hundredths as a decimal. Well, and if I already have it out of 100, then I know that this is 50%. So 50% is equivalent to all these other representations that we've already learned about. 1/2, 50 over 100, 50 hundredths as a decimal. They're all equivalent. It's the same thing. What about 1/10? Well, 1/10, it has 10 shaded in out of 100. That's going to make it 10 100ths as a decimal, or 10%. See what you can do with these two. If I have 1/5, how many 100ths is that? What about the percent? How about 3/5? How many 100ths is that? What percent could that be? So what did you find? For this 1/5, you should have 20 100ths as a fraction, 20 hundredths as a decimal, which is equivalent to 20%. How about this one? 3/5. Well, I'm thinking that if this one up here is 1/5, this is just 3 times as many, and it looks like it in the model. So if I had 20 100ths in the top, this one I have 60 100ths, 60 hundredths as a decimal, and it is also 60%. See the relationship between these two, where the 1/5 times 3 is going to be 3/5. And notice that the percent is just multiplied by 3 as well. These relationships make it really easy for us to manipulate and understand percents.